Welcome back to our Software Design and Development unit. In this lesson we will look at the Standard Algorithm Counting Occurrences. Our learning intentions for this lesson are as follows. We'll learn how to count how many times a piece of data appears in a list using a counting occurrences algorithm. As always, we have some success criteria, which today is as follows. We will be able to implement the counting occurrences algorithm and describe its operation. We'll start today's lesson with a definition. Counting occurrences is an algorithm that counts the number of times or occurrences that a specified piece of data appears in a list or an array. In a counting occurrences diagram, a requested piece of data and a list or array of items are compared with one another, and if they are the same, then a counter is incremented by 1. In this way we get a value returned on how many times the data item occurs within the list or array. This is repeated through the list until all the values are compared. Let's now look at an example. We'll do this by going through each line of data in turn, visually seeing how we traverse through the array, and we will compare each element in the array to our search value. We'll follow the values of each variable using our trace table. In line 1 we set the variable count to 0. We then enter the search term that we are looking for throughout the array. In this case, it's the name Dave. We then enter our fixed loop where we will iterate 10 times, 0 to 9. So therefore I in the first iteration will be 0. We will then compare the value at the first position of our array, which is student 0. That value is Julie, to our search value Dave. Now they are different, so at line 7 we will not increment our counter, it remains at 0. We will then iterate round the loop, I being incremented by 1 for our second iteration. Again, students I or students 1 this time is Dave, our search term is Dave, so therefore at line 7 we will increment our counter by 1. Again, we're back round the loop for our third iteration. Students I in this case is Alan, compare that to Dave. Again at line 7 we do not increment our counter. Again, back round the loop. This time it's 3. Students I in that element in index 3 we have the value John. Comparison, our counter remains at 1. Again, our next iteration of the loop, I becomes 4. At student 4 we have the value Dave, that is our search value of course, so therefore at line 7 we will increment our counter now to 2. Again, round the loop again, and we are now, I is now at 5. At that value of our array we have Kelly, and again that does not match our search term, our counter remains at 2. Around the loop I increments to 6. Our comparator this time is Molly, comparing that to Dave, does not match, therefore our counter remains the same. Back round the loop, I equals 7. Again, this time we do have Dave, they do match, therefore we're going to increment our counter at line 7. So count now becomes 3. Going round the loop for the second last time, incrementing I to 8. We have the value Julie being compared to Dave. Our counter remains at 3. And finally, we move round the loop to our last iteration. I is incremented to 9. Student I, in this case, will be Dave. Our search value is Dave, and therefore at line 7 we will increment our count by 1 to 4. At line 11, we will then display our finalised count, which is 4. Thank you for watching this series of videos. If you haven't already done so, please subscribe.